Hello guys, welcome to Learning is Fun, and this is a video tutorial on physics, introduction to physics. So before I go deeper into introducing us to physics and ideas and concepts in physics, I'm actually going to give us a brief history of how physics started. So to the end of the 18th century, the study of material things was treated as a single aspect of human thought, which was called natural philosophy. Let us note that natural philosophy. And with the increase of knowledge, it was now found necessary to divide the study of nature into two main branches, which were the physical sciences and the biological sciences. So let us note that also, because this is very important at this stage, noting all these important things that happened that gave birth to physics, chemistry, and other branches in science. So here we have it. Study of nature was now splitted into two, and we have the physical sciences and we have the biological sciences. So the, the physical sciences is concerned with the properties and behaviors of non-living matters, while the biological sciences focuses mainly on living things. So that's why you have the biological science, which deals with plants, animals, and other, even human beings, other living organisms like bacteria, fungi, and so on. While the physical sciences deals with the non-living aspect of life. So we have to note it also. Here we have the physical sciences, non-living things. Here we have it, living things. So the physical sciences also now gave birth to other branches in science, and the two main branch of the physical sciences are known as physics and chemistry. The two are quite similar, but chemistry deals with the action of one kind of substance on another, or deals with the composition of substances and the reactions they undergo to form new substances. If you take for instance now in chemistry, where you pour a spoon of salt into a certain amount of water, you find out that the salt dissolves in the water and you don't find the salt again. It has already changed form and blended with the water, so it all becomes liquid. So you can see that we're trying to look at the characteristics, the behavior of what is actually happening between two substances when they are combined. So that's what chemistry is majorly about. We're trying to just look at the reactions that would occur, or the changes that the substances will occur when you bring two or more substances together. So that's just what chemistry deals with. Whereas physics, which is our main subject of this discussion, we're going to actually be looking at it that physics is concerned with matter in relation to energy. So let us note that physics is the study of matter in relation to energy. So you need to start this also. So now we have the definition of physics, and we can look at it in a way that we try to study phenomena that occurs, what is the energy gained or released in the process. So we just try to relate energy to anything that we're actually doing, either a work done, either a force applied in pushing a cart, or any activity we want to do. So physics is like the major background knowledge that is fixed to each of these aspects of life that we want to do, anything we want to engage in. So we can say that physics look at how energy can occur in various forms and how it is being transferred. The study of physics at ordinary level or fundamental level may be grouped to headings such as mechanics, general physics, optics, wave motion, electricity and magnetism, and, and at higher level we can have solid state physics, quantum physics, special relativity, nuclear physics, and atmospheric physics. Each of all these branches of physics that we have, they are like different basic fundamental level and advanced level. So when we're trying to relate physics at an ordinary level, we try to just look at mechanics. Let me note that this is ordinary level. So we have mechanics, general physics, we have optics, wave motion, electricity, and magnetism. So we can so why at higher level we also have atomic physics also, but to a certain level at ordinary level, because atomic physics is like what gave birth to quantum physics, trying to picture things at the microscopic level. So that's what atomic physics, things we can't see with our naked eyes, that we have to use the use of some special instruments such as microscope to try and examine things that are not easily seen by the eye. Even you can't even see them with your eyes, because these are at a very small um atomic size, very small. So let us now look at some aspect of physics at advanced level. Advanced level, we could have plasma physics, we have solid state, we could also have nuclear physics, quantum, and this is a very interesting part of physics, very interesting. We have the ionospheric, and we can just classify this like that. So we have so many branches of physics at advanced level. We also have electricity and magnetism at advanced level also, but the ordinary level just gives us some basic ideas of dynamo principle, electromagnetic induction. But at advanced level, we'll now be looking at Maxwell's equations. So there are those, each of all those topics at ordinary level are now advanced in newer topics that are introduced into each of those branches at ordinary level, and now makes it to be broader and bulkier again in studying physics. So now let us now look at some properties of physics that we also experience in relation to matters. So you can see that certain properties of matters are measured and the result examined to see if there is any mathematical relationship between them. So therefore it is important to understand the true meaning of equations we find in physics textbooks. And these equations are simply a convenient way of expressing the laws governing their behavior. And this is the main purpose of science, to seek out laws of the universe and if possible to express them in precise mathematical form. So that's just why we have physics. All these natural phenomena we're seeing or experiencing in our climb, in anywhere we find ourselves, we try to find a way we can relate it mathematically to give us an accurate prediction of each of all these occurrences. So that's what science is just all about, trying to just give fact, because science is actually trying to give us fact about different events or occurrence that might occur in future or maybe in the present situation. So now I'm going to just talk about the type of quantities we experience in physics and how they are useful to us. So now the types of quantities and units. In physics, we generally have what we know it as physical quantities. And physical quantities are actually quantities that we can observe and measure to give us its magnitude, or we can say its size. So that's what we majorly use in physics. Physical quantities are quantities that can be measured to give its magnitude or size. And these quantities are now further divided into two types of quantities. We have the fundamental quantities or the base, or also called base quantities. So let me write that. We have the fundamental quantities or base quantities. And also we have the derived quantities. Derived. So these are the two major quantities that we have in physics that we actually try to use them to give them names of quantities that we measure, because when we measure them it actually give us a particular magnitude. So we have six major fundamental quantities, and they are: we have the mass, length, time, can say light intensity or luminous intensity. We also have the amount of substance, have temperature, also have the electric current. So these are the major fundamental quantity. And why do we call them fundamental or base quantity? Because we call them base quantity because they do not depend on other quantities. They are the quantities that make up other quantities, such as the derived quantities. So they are like the basic or the building blocks of other quantities. That's what they are majorly known as. And each of them have different units, but the generally accepted unit of each of all these quantities is what we term as the SI unit in physics. SI. And SI unit actually means System International. It is like a French word. So this is the generally accepted unit in all branches of physics, which cuts across physics. So this is what has been agreed across the whole world in all branches of physics. So I'm going to actually list out the unit associated with each of all these fundamental quantities. For mass, we have kilograms. For length, it is measured in meters. I'm just writing the symbols. For time, we have seconds. For light intensity, or also known as luminous intensity, we have candela. Amount of a substance, the unit is in moles. Temperature is measured in, the unit is measured in Kelvin. An electric current, the unit is in amperes. So each of all these fundamental or base quantities, these are their standard units or the SI unit of each of all these quantities. So derived quantities are quantities that are gotten from the fundamental quantities. Since I've explained earlier that the base quantities are like building blocks for other quantities, foundation. So now examples of derived quantities, we have the speed, we have force, we have distance, we have pressure, and so on like that. We have a lot of them, and the units we get from all these derived quantities are the derived units, and they actually use the fundamental unit because they're actually made up from the fundamental unit. So for speed, we have a unit of meter per seconds because speed is distance over time. Force is measured in newtons, and newtons is actually kg meter per second squared, or let me write it all, kg meter per second squared, writing it in indices. Distance is measured in meters, whereas force is measured in pressure, is measured in force per unit area, and that is going to be n meter raised to power minus 2. So these are those the units, the SI unit of each of all these derived quantities here. So let me just link it. So these are derived quantities here. So also we need to just talk about unit because we've been talking about unit since. So units are used to denote or describe each quantity in particular. So when we see any quantity that have or any magnitude that has meter per second, we are actually going to have a link that okay is going to be related to speed, or is going to be related to velocity, because velocity is just speed in a specified direction. So that's just, so when we were able to check our values or our magnitude that was given to us, and it have a particular unit associated with that value, we can be able to identify it. So the unit is also used to describe each quantity in particular. So if we have force, that means we have a value of 5 newtons, that means we're talking about force. So also we also notice different phenomena in our present environment due to the area or climate we find ourselves, such as rainfall, snowfall, dew, rainbow, mirage, aurora, which can be also known as the northern or southern light, and we have a whole lot of them. So I have aurora here with me. So this is a picture of aurora. An aurora is formed when the upper atmosphere is disturbed by solar winds, which consist of charged particles like the electrons and protons. So these are those different scenes or pictures of aurora, and I actually picked this from the internet, so you can google about it, you can see more images, check how it was formed and what its effect causes to our solar system. So each of these phenomena are best explained in physics in terms of energy and the energy produced or gained in the process. So that's why we mentioned that physics is the study of matter in relation to energy. So each of all these non-living things, all these phenomena that occurs, we want to just try and figure out what energy was produced, what energy was released, and we want to try and see if there's a mathematical relation that we can use to express such phenomena. So now physics cuts across a lot of branches in science, like material science, astronomy, chemistry. Astronomy, whereby we're talking about space, we're talking about the stars, the solar system, the extraterrestrial bodies outside our solar system. So we want to try and look at the energy that we can find there, phenomena that can occur, and other interesting things that we can't really understand. Physics try to bring and pieces each of this knowledge to mankind in helping us to understand it better. So also many developments or technologies are physics based, such as our mobile telephone. So let us just look at it. So how we use physics in our daily life, we have our telephones, we have modern day train track. We have train track whereby you see a train without having wheels, moving like an electromagnet. So try to just make it frictionless. So this is all applications of physics. We also have solar power devices, semiconductors in modern day computers, even high power microscope used in medical research, and we have a whole lot of applications of physics. So let me just note them down. We have semiconductors, solar power devices, and etc. So these are those applications of physics that we can see in our modern day life. So let me just show us a picture of great minds of scientists with different scientists because it was due their great intellect that brought more light and explanations to principles, and we have to just acknowledge them. That's why in physics, also in chemistry, which is kind kind of similar to physics, we have laws with scientists' name accompanied by those laws. So I'll just show us a picture of a group of scientists here. So here with me now, this is a picture of scientists at the Solvay conference of 1927. So we have each of them's name there. We have Einstein, we have Lorentz, we have Marie Curie. She was actually a scientist. She majored in radioactivity. We have Max Planck, which was like he was considered a predecessor of modern um, physics. We also have Dirac, we have Schrödinger, also one of the major brain in quantum mechanics because his famous equation in quantum mechanics really helps and it is used till date. We have a lot of interesting guys here, great minds, and each of them contributed to the success of science as a whole, physics also as a whole. So we need to get familiar with names of physicists. We also have the ones found in ordinary level physics, majorly like Isaac Newton, Sir Isaac Newton. So many other scientists like that will find their names: Hooke's law, Boyle's law, Charles' law. So each of all these scientists, most of them, their names are accompanied by some certain law which we need to memorize and we need to apply them in any calculation we need to solve. So there we have it, guys. Introduction to physics. So if there's any comment or suggestion, kindly drop them below, and if this video was educative, please kindly click the like button and subscribe for more. Thank you.